Don't move it. Oh, it's on. Right. The cubic polynomial is defined by x cubed minus 19x plus 30. This was a great question, wasn't it? Given that x equals 2 is a root, well, you've got 1 mark for recognising that if that says that x equals 2 is a root, then you're going to do it as being x minus 2 times something. Now, however you got the something was up to you. So some people did the full-on long division, which is fine. It was a lot of work for just 3 more marks, but still, it kind of got 2 more marks really. It got there. Some people did it just by inspection. Some people used the quite nice, really liking the grid method, which says that this first thing here is x cubed. So what do you multiply x by to get x cubed? The answer is x squared. X squared times minus 2 is minus 2x. Squared. We're supposed to have no x squareds. We've got minus 2 of them. We must have plus 2 of them up here to get rid of them all. X times 2x would give us that. Let's change colour for no apparent reason. So now, is that right? Yes, 2x times minus 2 is minus 4x. We're supposed to have minus 19. We're way short. We need to take away another 15x. That's 19. So minus 15x. So that must be x times minus 15x. Anyway, it's minus 15. Oh, this is going great now. Minus 15 times minus 2, random change of colour, is plus 30. Oh, we wanted a plus 30. Bargain. Right, so we're done. We've got x squared plus 2x minus 15 as our thing in there. Ace grid method. Right, well, what next? The question said, express it as the product of 3 linear factors. At this point, we've got 3 out of 4 marks. Because it said 3 linear factors, we know that this has got to factorise, and it's a fairly simple quadratic. So our final thing to do is to say that f of x is x minus 2. What is it? It must be x and x. It must be 5 and 3. It must be a plus 5 and a minus 3. That would work, wouldn't it? So that gives us our fully factorised cubic. 4 marks. Then I thought that the second part was kind of almost independent. Didn't rely on you doing any of that first bit. Use integration to find the value of the integral from minus 5 to 3 of x cubed minus 19x plus 30dx. It was quite nice, this, wasn't it? Because even if you'd panicked about part 1, if you'd got nothing in part 1, you kind of had a fresh start in part 2. You could get all of the marks, didn't depend on anything there. Obviously, you're going to get lots of marks for just demonstrating your knowledge of integration. So add 1 to the power, divide by the new power. I think they gave 2 marks just for doing this. The third mark is for putting the limits in. They must be the right way round. So you put the top one in first and subtract what you get when you put the bottom in. 3 to the 4 over 4 minus 19 times 3 squared over 2. Plus 30 times 3, take away minus 5 to the 4 over 4, minus 19 times minus 5, squared over 2, I've run out of space. Don't know why you extended the page out. Plus 30 minus 5, close that bracket twice, there we go. Now, that is your third method mark for showing the subtraction. You could do it there. You could be really careful, type all of that into your calculator in one go, and come up with the right answer. You could do that, or you could work it out in smaller bits. Is it 2, 5, 6? Does somebody do this and get the right answer? Is that right? There we go. Okay. Part 3. Over the page, we were given a little space to sketch it. Part 3 says, explain with the aid of a sketch why the answer to part 2 does not give the area enclosed by the curve and the x-axis between -5 and 3. So we're going to do a sketch, aren't we? And our sketch is going to be of this graph. Well, part 1 was kind of sorting the sketch out for you. Part 1 gave you the points where it crosses the x-axis. So +2, -5 and +3. That number hanging around there is the point where it crosses the y-axis. So our sketch, as long as you've got that bit right, should be fairly easy to do. It's going to be a graph that does something like that. There we go. You didn't have to mark all the points, but you could have done. That point is 30 where it crosses. I don't know where the maximum is. We're not that bothered about where the maximum is, whether it's on the axis or not. You get away with it if you drew it on the axis. But that's what the graph looks like. And so 1 mark for doing that. Now, why is that not? How can you show that the integral that you did doesn't give you the area enclosed? So the area enclosed is that area there and that area down there. And it was quite specific what it was looking for with this. You had to actually acknowledge, you couldn't just say how you would find the area, you had to say why it didn't give you the area enclosed by the curve and the x-axis. And so the reason is that the area between 2 and 3 is underneath the axis. So we contribute a negative amount. You have to give some specific reference to that area being underneath the axis and therefore negative, and therefore subtracting from the total, contributing a negative amount to the total that you find. You could even say that what you ended up getting, the value that you got 256, is the difference between these two areas, taking that one as positive and that one as negative. What they didn't want you to do is they didn't want you to say, to calculate the exact area, you need to do the integral from -5 to 2 and the integral from 2 to 3, because that's not what the question asks for. It's say how to get the right area, it's why is your area not the right area. All right. And that's maths. Thank you.